Hi everyone, welcome back to my channel, and today I am going to discuss the Pareto optimality in consumption. So, Pareto optimality in consumption means a situation when one consumer cannot be made better off without making other worse off. So, to explain it graphically, I'll take a 2 cross 2 system, two commodity and two consumers in a country. So let us consider in a society there are two consumers, consumer 1 and consumer 2. And they are consuming two commodities, commodity X and Y. So if we say small x is the total production of X and small y is the total production of Y. So Pareto optimality means a situation in which you cannot think of any kind of Pareto improvement. So the necessary condition is that if X1 is the consumption of X by consumer 1 plus X2, that should be equal to total production of X. So if we see that X is greater than X1 plus, if it is greater than X1 plus X2, that means the consumption of one person can increase without reducing the consumption of the other person. So this is called Pareto improvement. That same thing will be, same condition will be applicable for Y. So I'm not going to show this now. So this is the necessary condition, but this is not the sufficient condition. So to create the necessary and sufficient conditions, what we have to do, we have to use a box diagram, which is called the Edgeworth box diagram. And also, I have to mention here one thing, that the utility functions of two consumers that I am taking are that will behave utility functions, or the standard utility functions from which we get the concave, the indifference curves that are convex to the origin. So diminishing marginal rate of substitution between X and Y for both consumers. So in this box diagram, so there are two origin points. This is the origin of individual 1 and this is the origin of individual 2. So whenever we, from O1, whenever we move in rightward direction, that means consumption of X by individual 1 is increasing. And similarly, whenever we move upward direction, that means consumption of Y by individual 1 is increasing. So similarly, if we move in this downward direction from O2, consumption of consumption of Y by individual 2 is increasing. And if we move in this direction, then we can say, so definitely if we start from the origin, so these will be the indifference curves, and if we move to the higher indifference curves, the utility of individual 1 will increase. And if we move in the opposite direction, then what we see? So if we consider this type of indifference curve, so as we move in this direction, we can say the utility of individual 2 is increasing. So we have to find out those points on which if individual 1's utility is increasing, that means that is bound to reduce the utility of individual 2 and vice versa. So according to Pareto, what are the consumption efficiency points? Similarly, where the indifference curve of two different individuals are tangent to each other. So if we join this diagram, so I have got this type of your locus. This is called the consumption efficiency locus. So why are we calling these points Pareto optimal? Where the two individuals indifference curves are being tangent to each other. Look at this if we compare A, B and C. So see, A and B are the Pareto optimal point, but C is not a Pareto optimal point. So if we see that moving from C to B, what do we see? The individual 1 is moving to higher indifference curve, whereas individual 2 is on the same indifference curve. That means from C and Pareto improvement is possible. Similarly, we can move from C to A where the individual 2's utility will increase without reducing the utility of individual 1. So every point of this consumption efficiency locus, this is called consumption efficiency locus. Every point of this curve indicates Pareto optimality in consumption. That means there is no scope of Pareto improvement. Now, so what we see here, the ultimate condition comes from here. Ultimate condition that comes from here is called Pareto optimality in consumption, that indicates marginal rate of substitution between X and Y for individual 1 will always be equal to marginal rate of substitution between X and Y for individual 2 will be same. That indicates the tangency point between the indifference curve of two different consumers. So from here we can draw the consumption possibility locus of a society in a two commodity, two individual space. So we need not bother about how many commodities are there. We can think only two individuals are there. So if we, in horizontal x, we are measuring the utility of 1, and the vertical axis, we are measuring the utility of 2. So from here, what we see, this will be the consumption possibility locus, which will be downward sloping, because any point on this indicates the Pareto optimality. So that means there is no further possibility of Pareto improvement. So just to compare any other point inside the curve, if we consider A, so what we see, that utility of individual 1 can be increased without reducing the utility of individual 2. So this is a Pareto improvement. Also, we can increase the utility of consumer 2 without reducing the utility of consumer 1, or we can increase the utility of both consumers. So A is a point, A does not indicate Pareto efficiency. Rather, we can say from A, Pareto improvement is possible. But once we reach here on this curve, that means there is no further Pareto improvement is possible. And we cannot go beyond this because the resources or the commodities produced in the country or commodities produced in the society cannot allow this point. So this is our Pareto optimality in consumption, from which we derive the consumption possibility of locus, and finally the consumption, first we, in the box diagram, we derive the consumption efficiency locus, and this is the consumption possibilities curve of a society. So we end here today. So later on, I'll come back with Pareto optimality in production. So till then, goodbye, and thank you for watching my video. See you soon.